Ngizolijabulela lolu hlelo.
Sanibonani grade 12 sesihlangene futhi for physical sciences. Sasikhuluma last week about electrochemistry. Sayichaza kahle in terms of redox reaction, oxidation, reduction, and we need to know this definition. Sithe define oxidation either in terms of electron transfer noma in terms of oxidation number. So that the oxidation is the loss of electrons and reduction is the gain of electrons. Must define in terms of oxidation number. Sithe ukuthi oxidation is an increase in the oxidation number and reduction is a decrease in oxidation number. Then sikhuluma nge-galvanic cell. Sibuka ngokuthi galvanic cell will transform chemical energy into electrical energy, and we had the setup esnika galvanic cell. Then sagcina sikhuluma nge-cell notation, and we had an example efana zinc reacting with copper, right? And cell notation sithe ikhombisa bani the anode side ne cathode side of the cell, right? That is it. Then kwenzeka ukuthi mawubuka i-cell or noma galvanic cell ubona ukuthi i-electrode yakho mhlambe that will be the anode noma i-cathode on the other side ibe i-substance that is not a solid, ngoba ngikhumbula ukuthi sasine-example eveza i-galvanic cell of copper and zinc, right? Namhlanje ngifake u-copper ngala, ngifake u-zinc ngala. I-zinc ifanele ibe bani kwi-zinc solution, zinc 2 plus hlangene no-SO4 2 minus. Copper ifanele ibe ku-copper solution, Cu2 plus no-S4 2 minus. Then that uyakwazi ukuhlanganisa lama, sifake mhlambe ammeter ngala connected, then kubuye ngala. This was called a salt bridge. Nisakhumbula i-role, i-function ye-salt bridge uthi yenzeka sifake u-salt bridge to maintain a neutrality of lama solutions. Siphinde futhi senze njani, iphinde i-complete i-circuit, right? Zinc and copper. Manje sithe ukuthi zinc will be oxidized, kusho ukuthi ama-electrons azosuka ku-zinc aye ngala ku-copper. So zinc is the anode, then copper here is the cathode, right? Is the cathode. Now uyabona ukuthi zinc and copper both are metals. What if zinc mhlambe ureacta nani ne-chlorine gas? Manje uzobona ukuthi siba ne-challenge ukuthi masi i-reacta ne-chlorine gas asikwazi ukuthi intambo so-connect emoyeni or in the gas, sidinga esinye structure senza ukuthi sikwazi uconnecta to the external circuit. So structure kumele sebenzise a substance noma i-metal that is inert, zinc and chlorine. Now chlorine so idlulisa ku-tube enje cause it's a gas. Bese sifaka intambo or a metal rod that is solid ezokwazi ukuconnectisa outside the circuit, right? Then ngala we have what? Our zinc. We still have the zinc electrode. Ngala you have zinc. Ngala sithe kungena bani chlorine. Chlorine is a gas, so sifaka bani Cl2 gas. Now this part here, this electrode here, it has to be either platinum noma abe carbon or graphite, right? Now why do we use this? Ingoba sifuna ukuthi isinike i-structure where i-oxidation noma a reduction will take place. Ngoba we have the gas chlorine azikwazi ku-connecta kwi-gas, so nala ifanele sibone ukuthi kuzowenzekalani. Still we have a salt bridge we have a salt bridge. So this metal here, we use it, one, ingoba it's a solid, two, it's an inert metal, kusho I react the solution, and three, is a good conductor of electricity. So ingakho sebenzisa bani platinum noma carbon, a carbon or a graphite. Sebenza ukuthi it's a solid, one, it's a good conductor of electricity, two, it is inert, so ayihlangene ne-reaction izokwenzekalana. So it is just allowing us to connect to the external circuit and also give us a structure, a solid structure, where the oxidation or the reduction will take place. So mangibuka zinc and chlorine, kusho ukuthi chlorine will undergo reduction, zinc will be oxidized food, right? Now masenza i-cell notation, ngoba sithi zinc will be oxidized, so our cell notation uzoba zinc sithi solid, kwaphenduka bani zinc 2 plus, aqueous, salt bridge, nasikhuluma nge-chlorine. I-chlorine iqala nge-half reaction, njengoba i-reduced i-chlorine izoba u-Cl2, a gas, mase kunika bani u-Cl minus, aqueous. Then uyabona-ke ukuthi asikwazi kuba ne-electrode eyi-aqueous noma electrode ebani e-gas. So we need what? Another substance. Ileyo substance ebezingani platinum. So sofaka lo platinum mase sithi solid. Ngoba mawubhala i-cell notation kumele uqale nge-solid ugcine ngani? Nge-solid. Kodwa-ke masithi which substance is oxidized? It's zinc. Is oxidized, yaphenduka bani zinc 2 plus. So zinc is the reducing agent, is the one that is oxidized. Mese sizangala noma ngala sotini, what is the anode? The anode we have here is zinc. So zinc is also the anode. But zinc is also oxidized. It's undergoing what? Oxidation. It is the reducing agent. Mesiza ngapha kwi-chlorine. Chlorine is the one that is reduced. Chlorine is the one that is reduced, is the oxidizing agent. But chlorine is not the cathode. Cathode wethu bani? PT. So when you see the platinum here, it's just the role of the cathode. Ngoba umbuzo ngati write down the formula of the cathode. Most of the time abafundi bajwayele ukwenza njani kupambanisa i-cathode ne reduced substance. Right? Kungaba ukuthi kube reduced but kungabi yona i-electrode at the same time. So you see that the platinum wala it's not reduced. So if chlorine yona bakwi anode side, still beso sebenzisa PT, then it's chlorine and so on and so on. So the role of PT here is just what? The electrode. Makutiwa write down the reduction half reaction. Actually on PT, that platinum that was reduced. It was chlorine that was reduced. Right? I hope we understand. Sakumbula ne function here is salt bridge. Then njengoba sine cell kumele sithole ukuthi le current ehamba ngala idependela kuyini, ngoba sithe the zinc masibhala i-net redox reaction, right? Asibuyele ku example yethu uqala yayithi zinc ne copper, right? So zinc and copper bese sibalansisile futhi le equation, size kwakho zinc reacting with Cu2 plus kwaskiphela zinc 2 plus plus Cu. Now this reaction here can be what? A reversible reaction. Ingaba irreversible reaction because by the time lo copper lo thola ama electrons uyayigena potential, lo zinc lose ama electrons. So ngenzeka kube the point ngoba kuyi reversible reaction singafika ku point of equilibrium ukuthi copper is now saturated, right? So at point of equilibrium sesingasebenzisa bani le Chatelier's principle. Siyazi ukuthi the Chatelier's principle will allow a system to do what? To reinstate equilibrium by favoring the reaction that is disturbed, that will oppose to the disturbance. Zinc plus Cu2 plus. Zobona ukuthi bazothi what if si-increase i-concentration ka-Cu2 plus kuzokwenzekalani kule ammeter reading. Fanele njalo sibuyele ku-equation. Yabona-ke maku-increase ngala seku-increase ama copper 2 ion kwama reactant. So with Le Chatelier we'll try to decrease the concentration. Kusho ukuthi i-forward reaction will be favored. Makuthi forward reaction is favored, kusho ukuthi i-current izo increase. Any condition ezo favorisha i-forward reaction will make the ammeter reading to increase. Kodwa may favorisha i-reverse reaction, then it will make the reaction to the current or the ammeter reading to decrease. Lokhu kufana nokuthi bathi let's increase the concentration ka zinc 2 plus, right? So we increase ngala. So with Le Chatelier, the zinc ion will tend to be reduced. Now to be reduced, kusho ukuthi a reverse reaction will be favored. Lokhu kuzo affect abani i-ammeter reading. Now, khona into ifanele sisebenzise i-table of standard reduction potential. Angisithi si create i-current. So ifanele sibone ukuthi the EMF that will be produced ingakanani compared to the metals that we have. So sebenzisa ini a table. You'll be given two tables like this. Kona a table 4A, no table 4A, in the table 4B. Right? The same table and just that lana kala ngo fluorine, kutina ngo lithium. This one kala nge lithium, itkine ngani nge fluorine. So mina ngifuna table 4B for now. Lithium lo uphezulu. Njengoba ebhalwe kanje, it's written as ama reduction half reactions. Wonke ama reduction half reactions. So uzobona ukuthi lithium ibhalwe ngathi A plus E minus, that gives you what? Li. Mase kune double arrow. Don't ever put the double arrow. Le double arrow khombisa ukuthi lento ngenzeka ishone ngala noma ebuyele ngala. Right? Now, let me take another element here. Ngizothatha sodium ngoba sesike sayisebenzisa. Ithi Na plus E minus uzinika bani Na. Now, when there are double arrow here, it shows that you can write Na plus E minus, give us Na, kodwa at the same time ungakwazi kuyiphendula lenuthi Na isikhiphela bani Na plus E minus. Why kube naleyo possibility? Ngoba it always depend ukuthi lo sodium u reactor nani. Kungenzeka ukuthi I react ne metal where I sodium will gain ama electrons, but kwenzeke futhi a react ne metal where sodium will donate or will lose those electrons. So lokhu ukuthi mawushona from left to right ukuthi it is reduced, mawukuthi right to left, that is oxidized. Right? So ngala sodium was acting as the reduction half reaction, kanti ngala sekuyi oxidation half reaction of the same metal as sodium. Right? Now table 4B, if singafuni confusion, let's use table 4B namhlanje. Uzobona ukuthi mo comparisha ama metals, ama element awu2, uzothola kanjani which one will be oxidized, which one will be reduced. Ngiyakhumbula ngesikhathi nginika example ye chlorine no zinc, I knew ukuthi zinc will be oxidized, chlorine will be reduced. Ngisebenzise le table, right? So ma ngisebenzisa ama element awu2 kule table kuyasho ukuthi khona le arrow ekhombisa ukuthi as you go up you are increasing what? Reducing ability. As you go down, you are increasing oxidizing ability. Kusho ukuthi le phezulu iyakwazi ku reduce le ephansi kunayo. So the one that will be on top is the one that will be oxidized, the one at the bottom is the one that will be reduced. Ngisho lokhu ma usebenzisa table 4B. Table 4B. So njengoba ku oxidized lokhu phezulu ku oxidized, the one at the bottom will be reduced. Right? so uyisebenzisa kanjalo. Then kukunika bani i-number la zikhombisa i-cell potential. Bona for example zinc cell potential uthi bani negative 0.76. Bathole kanjani lo negative 0.76? Ingoba bekade besebenzisa hydrogen, i-hydrogen electrode. So hydrogen was our standard electrode. So each and every metal abo hydrogen ila, right? So ubona cell potential yakho bani u0. Kusho ukuthi bekuthatha i-hydrogen bayihlanganise ne-lead bathole i-reading, bayihlanganise no-nickel bathole ama-reading, wonke lama-reading lawo enziwe relative to hydrogen. So hydrogen was the standard electrode, right? Now okunye khombisa ukuthi sometimes hydrogen will lose electrons, but sometimes can also gain electrons. So it means it can act as, it can be reduced or it can be oxidized. Here depend, right? A 0 is the standard electrode for this one. Kodwa ke siyazi ukuthi le reaction, it is a reversible reaction, and siyakhumbula ukuthi kwi-chemistry ngesikhathi senza equilibrium akhona ama-factors that will affect what? Chemical equilibrium, and those factors were including concentration, pressure, temperature, right? Now ukuthi sithole le number, lezi number lezi ingoba kufanele senze at the same temperature, same pressure and same temperature, same concentration. So lawo siwabiza ngani ngama standard conditions, standard conditions, yabo standard condition, ngoba siyazi ukuthi mashinja nje i-temperature nalama values lawa azoshintsha. So all these values were calculated under the same conditions of temperature, pressure and concentration. So kya depend ukuthi maune gas sungakhuluma nge-pressure, but maune aqueous solution sungakhuluma ngani nge-concentration. So lama conditions ati the temperature kumele kube bani 25 degrees Celsius, yoni condition. So kusho ukuthi wonke lama values lawa lezi number lezi for potential, the electrode potential, they were all run under 25 degrees Celsius. So the temperature is constant for them. The concentration for any aqueous solution kumele ibe 1 mole per decimeter cube. Kumele kube 1 mole per decimeter cube. That is the condition for concentration. For pressure, fana kube atmospheric pressure 1 atm, noma soti 101.3 kilopascals. Right, kusho ukuthi lezi number lezi zithole under these conditions of temperature, concentration and pressure. Ingoba siyazi ukuthi the temperature can favor any reaction, so kungashintsha ke lezi number lezi, right? Then sometimes mase ubhala i-cell notation, kungenzeka kuthiwa with your cell notation include ama standard conditions, standard conditions. So zothola ukuthi mengina le example nje solid law angifaki lutho, aqueous next to it ngizothini 1 mole per decimeter cube ngoba ku aqueous solution. This one is a gas, next to it ngizothi 1 atm, right? Mase egcineni ngala ngizothi 25 degrees Celsius, right? So that it. But if the cell does not contain a gas, like this example here, lana ngizoti 1 mole per decimeter cube, lana ngizoti 1 mole per decimeter cube, mese ngithi 25 degrees Celsius. Yabo uthi pressure ingenanga ngoba anginayi gas. So that's how you do it. Then again, you can be able to calculate the cell potential. What is the cell potential? Cell potential calculator as E cell is equal to E cathode minus E anode, right? So I'll take the first example. The first example is a copper 40 as a cell notation. So if I want to find what is the cell notation, ngala, so T, E cell, E cathode, in our case i-cathode behambisana nani ne-copper, so ngifunda i-value ya-copper. The copper here is given copper nangu copper 0.34 yamthola ke copper uthi positive 0.34, so ngizothi lana positive 0.34 minus minus ngithola kwi-formula, then ngibuka i-zinc cell potential zinc is here uthi negative 0.76, so mangihlanganisa ngizothi bracket negative 0.76, then ngisebenzisa calculator, so ngizothi 0.34 plus ngoba minus ukhiphela plus 0.76 sengithola bani 1.1, so i-cell yethu izokhiphela i-voltage ethi 1.1, so that's how you calculate it. Ngesinye isikhathi bayakwazi ukuthela ukuthi look for find out what is the metal that you are using, a metal that you are using. Let's say bakunika hlambe i-cell kuthiwa yenziwa silver silver Ag, bese bakunika ke okunye lana bathi le metal X, right? Bakunika ukuthi this one is a metal X, right? Bese kuthiwa the cell, the E cell of this galvanic cell ubani 1.07 volt. Bese kuthiwa that the mass noma kuthiwa ama electrons they move from X to Ag to silver. Electrons move from X to Ag. Noma kuthiwa the mass of X decreases and the mass of silver increases. Lokhu kuyasho ukuthi X is being oxidized while silver is being reduced. Noma makuthiwa i-direction, angithi siyazi ukuthi ama-electrons asuka kwi-anode aya kwi-cathode, kanti siyazi ukuthi anode it's where oxidation takes place. Kusho ukuthi the metal X is being oxidized. Mase kuthiwa if the E cell is 1.07 ubani ke u-X, what is the metal X? Identify metal X. Same thing, sebenzisa the same formula. Siyazi ukuthi formula ithi E cell is equal to E cathode minus E anode. Sesiyamazi u-anode no cathode ngoba basinikile i-clue ngokuthi the mass of X decrease, and siyazi ukuthi the mass of the anode is the one that decreases, the one for cathode is the one that increases. Noma bangasinikanga leyo clue bazositshela ukuthi ama-electrons are move from X to Ag, and siyazi ukuthi ama-electrons ahlezi aphuma asuka kwi-anode aya kwi-cathode. Babangashongo lokhu khona indlela nje bazokhombisa ukuthi ama-electrons are move from which metal to which one, ukuze uzokwazi what is the anode, what is the cathode, so that when you write the formula, nosebenzisa le formula ethi E cell is equal to E cathode minus E anode, right? So uzothi E cell unikezwe to 1.07, E cathode so yazi ke silver is the cathode, so silver njengoba kuyi-cathode uyakwazi ukuthola i-value usebenzisa futhi i-diagram i-table. So silver unobani 0.80, 0.80 bese kuba minus E anode, so yazi value X is the anode but awumazi ukuthi what is X, right? Bese uya solve. Masu solve lokhu uzuzangala, so it gonna be 1 minus 1.07 minus 0.8 kusinika bani 0.27, but kuna ne negative sign ngala, so at the end u-X uzoskiphela bani negative 0.27 volt. Njengoba sithola negative 0.7 volt sibuyela ngala sifuna bani negative 0.27 nango negative 0.27. Negative 0.27 uhambisana nani no nickel, so kusho ukuthi i-metal X yethu bani nickel. That's how you work it out, right? So Yeah, that is one thing finally says in galvanic cell. How do we use a galvanic cell to solve a yoking? Right. The next cell esokhuluma ngayo ibizwa ngani electrolytic cell. Electrolytic cell. Electrolytic cell. The first one was a galvanic cell. Now you have electrolytic cell. Electrolytic cell. Now this electrolytic cell converts electrical energy. It converts electrical energy into chemical energy. Chemical energy. Right, that is an electrolytic cell. Ku electrolytic cell fanele sazi amagama afana nani ne-electrolyte. Electrolyte siyawazi we define from grade 10. A solution that conducts electricity due to the presence of free ions, electrolyte le. Mese kwenzeka futhi ini electrolysis. La ma definitions abangibuza ngayo electrolysis. Electrolysis. The electrolysis is simply what? A process where a chemical reaction is produced by a chemical and an electric current. So the electric current produces what? A chemical reaction. Kusho ukuthi ku-electrolytic cell so sebenzisa manje i-battery or a cell in order to have a chemical reaction to take place. Kanti kwi-galvanic cell besenza ini i-opposite. Besebenzisa chemical reaction kuphume bani electrical energy. Manje for electrolytic cell sebenzisa electrical energy ukuze kube nani ne-chemical reaction. Right, now i-structure sakhona simi kanjani in terms of electrolytic cell. The structure here will be a bit different with structure say galvanic cell. Structure sayo sine electrolytic cell electrolyte eyodwa, then you have electrode ngala uphinde ube nenye electrolyte mase siba nani siba ne battery or a cell that we connect there. Right, then this will be what? A solution, a salt solution that you have here. Now if battery has uno plus kuna minus, then you have this electrode. Now we have two things umele si understand in terms of electrolytic cells. Ngoba kune solution eyodwa. Now the solution or the salt that you have here or electrolyte, it can either be a molten salt noma ingaba is salt solution. Is salt solution. Molten salt kusho ukuthi there is only what? Let's take an example of sodium chloride, right? So it means a molten salt only sodium. It was exposed to heat until it breaks into ion. Right, so nginani ngino Na plus, nginani futhi no Cl minus kule solution. Now what will happen is that yabona ukuthi le part le is connected to the negative of the battery. Now because of that, this sodium here will shift ngala ngoba kune attraction izokwenzeka, and then ama electrons ezangala afike ngapha. So kusho ukuthi le sodium ion izangala ngoba ifuna ukuthola ini ama electrons. Kusho ukuthi the sodium is doing what? Is gaining ama electrons. When it's gaining ama electrons, it becomes what? A sodium metal. A substance that gains electrons, it undergoes what? A reduction. Kusho ukuthi ngala kwenzeka ini? Kwenzeka a reduction. Right? Sodium undergoes reduction because it's gaining ama electrons. Now this electrode is the electrode where reduction takes place. Kusho ukuthi siyibiza ngani? I-cathode. Kusa i-cathode yetu. It's a cathode because reduction takes place on it. Mese siba na le electrode yesibili. The electrode yesibili is connected to what? To the positive of the battery. Then the negative ion will be shifted ngala. So simono ukuthi le chlorine le, right, is lose an electron. The substance that loses an electron is oxidized. Right, so this will give us what? Or Cl2, that's 2E minus. Right, then isi balancile. So chlorine is oxidized kule kule electrode. So because this is where a oxidation takes place, so the electrode so ibiza ngani nge anode. That is the first thing. Lokhu kulula ngoba besebenzisa bani molten salt. What if asebenzisa molten salt sebenzisa bani salt solution? Yoma sithi salt solution, it means kune presence yani ye solvent, and solvent esisebenzisayo kwa amanzi. Now we have a salt solution. Yabo lokuqala kwakuyi salt liquid, as a pure liquid. Mawibhala uzothi NaCl mesothi L. L for liquids, pure liquid. So electrolyte yako is only containing a sodium ion nama chlorine ions. Then sikhuluma nge-salt solution. I-salt solution sinayo izobabani NaCl mase sithi AQ. Lo AQ, you know the meaning, kusho ukuthi water is there. So ngamanye amazwi sinane sine sodium ion, kube ne chlorine ion, phinde kube nani H2O. Sekhona ama substances awu 3 in that particular container. But initially besina 2. So the same thing we'll do. We have this one. Now konani kona Na plus, kono Cl minus, sekuno H2O. That is a third substance. Unlike the second one, the first one besina ma ions out kuphela, one positive, one negative. So we knew ukuthi kuzobalula isodium ngobe positive izozangala, chlorine ngobe negative izozangala. But masibuga sibuga amanzi H2O and sibuyela kule table futhi sobona ukuthi water as a substance on its own, it can be oxidized and it can also be reduced. Water as a substance. This is the first one. Yabo ngala siti amanzi. When you use this table, makutiwa tola a substance that undergoes reduction. Uifuna ngala on your left side. This is the side where you look for a substance that will be reduced. Makutiwa look for a substance that will be oxidized. Uifuna ngala. Ngoba suga ngala from left to right senza a reduction. Kotomasi funda from right to left senza oxidation. So all the substances otolangala left ngala, right? All these ones will be reduced. Kanti all of these ones will be oxidized. Now, mankuluma nge reduction ngibona nanga amanzi ngala H2O plus 2E kuskipela bani negative 0.83. It means water is reduced. Mangfuna water that is oxidized. Angisasebenzisi le formula le equation le ngoba ngifuna amanzi ngala for a substance that will be oxidized. Mangibuka okay ngibona H2O kodwa kuno SO3, ngifuna H2O kuphela, right, on this side. Nangu H2O no, there is NO3, so ngala H2O then nango ngithola bani H2O positive 1.23. Kono munye H2O ngala kodwa kono H2O2. Into siyaziyo ukuthi water is formed when H2 reacts with O2, right? Lana angithathi le equation ngoba khona bani sekuno H2O2, so I can't take that one. So that is the other one. So water can be oxidized and water can be reduced. Now asibuyelela masizangala kwi negative ion, so sibona ukuthi isodium izozangala, but at the same time water will also come this side ngoba isodium want to be reduced, but at the same time water want also to be reduced. Fana sibuyele ngala kule table sibona ukuthi between water and sodium ion, which one can be easily reduced, right? So ngala sibona ukuthi water is here, sodium is nanti la sodium iphezulu. Sitheni when we read this sibona ukuthi the one on top can easily be oxidized, the one at the bottom can be reduced. So makuthi compete between sodium ion namanzi kusho ukuthi amanzi will be be easily reduced. Kusho ukuthi amanzi is a stronger oxidizing agent than sodium. So what will happen? Sodium angeke ibe reduced, amanzi will be reduced. Mese uyakhophela ke kopela la a reduction half reaction of water. So it is 2H2O sniga plus 2E minus skipela OH2 gas plus 2OH minus. So sodium was not reduced ngoba beyicompete nani namanzi. Akufani ngecase yokuqala bekune sodium kuphela, sodium ion. Lana kune competition, right? So you use the table. This table will assist you a lot, right? Ngoba ama equations are already balanced in terms of ion, in terms of charges. Make use of this table every time, especially when you deal nani ne chemical ne electrochemistry, right? Asiyeke ngino mese sibuka bani chlorine. Chlorine will shift ngala ku positive electrode ngoba ifuna kuba oxidized, but at the same time water again can also be oxidized. Water comes this side. Kahle water acts as ngathi nesicefe makuthi kuya oxidizwa ifuna ukuya khona, makuya reduce still also want to go there. So kusho ukuthi amanzi will compete no Cl minus. Sibuyela ngala futhi, but this time sibuka amanzi that will be oxidized, not lawa are reduce again. So from what we see here, so bona ukuthi chlorine ngoba une high concentration ngala, chlorine will be oxidized. Or the easy rule is that when the salt is a salt of a halide, a halide can be a metal fluoride, metal chloride, metal bromide, metal iodide. When it's a salt of a halide, ileyo halogen, ileyo halide will be oxidized, ukipelebani the corresponding halogen. Kusho ukuthi uCl minus wona uzoba bani uzoba oxidized. So Cl minus, not water, that will be oxidized. Kipelabani or Cl2 plus 2E minus, then you have it. That is a rule. When the salt, and it is salt, it's a metal, can be sodium chloride, sodium bromide. Mamono kuti kuna chloride somewhere, kuna fluoride, kuna bromide, noma kunani iodide. Then you know this one will be oxidized. But if the salt is a salt of a carbonate or a nitrate, normal sulfate, then you know water will be oxidized, not the other negative ion. Right, that is the main thing. Then must you understand a lot next time first couple ukuthi is it a salt solution? Normal is a molten salt. Molten salt it only contains what? Ama ions, the ions that we have in the salt. Kotamu solution, beside on top of lama ions there is also water. Water can be oxidized and water can be reduced. But as I said, kule table, water being oxidized is not the same formula as same equation as water being reduced. Akufani ne copper, masiti copper for example, sishona from left to right, maguti it reduced, sipinde C7 from right to left when it is oxidized. For water is a different case. Sinani sine copper, sine water on the left side, gala sine hydrogen, it's no longer water, right? So we have water being reduced is the one with negative 0.83, and water being oxidized, let's nigga positive 1.23. Right, so that is what you need to know about the electrolytic cell. Then the next thing ile ama yama electrode. Sometimes ama electrode abuye abe nani abe reactive. Ngizosebenzisa NaCl futhi kule example. Right. Now, the electrode engiwasebenzise lana will be what? A platinum, noma ngisebenzise a graphite. Yet graphite is also what? A carbon. So ngizosebenzisa carbon. When it's a graphite, noma a carbon, yona I react. Now, if I have sodium chloride, then mhlambe ngisebenzisa ngithi ngithathe example ya copper chloride solution, right? Then ngisebenzisa i-copper electrode. Mangisebenzisa copper electrode ngizobona ukuthi ngino Cl minus ngine Cu2 plus, right? At the same time noma ngafaka amanzi, it's fine. Then it's a competition again, Cu ngala no H2O ngala, Cl minus ngala, and H2O ngala as well. Then sibona ukuthi Cl will be oxidized. But now lana khona ne copper, there is copper. If there is a presence of copper, this copper can also react with the solution. So in that case, you will see ukuthi a copper ion will also be oxidized. A copper will be oxidized. Mangbugi chlorine, for example, between chlorine and copper, which one can be easily oxidized? About a solution, govasite copper will shift ngala, it compete nani with water. So which one will win between copper and water? Gizangala, copper to be reduced, copper, copper nangu copper ula, copper is here, and water to be reduced ila. So because copper is below water, as we said kule diagram, every time when you have the table 4b, the one at the bottom will be reduced. So kushoguti copper will be reduced. So pala ini reduction half reaction ga copper, not water. Kushoguti lana copper will win it. So the reduction half reaction is the 2 plus 2e minus kipela bani Cu. Copper is reduced. Then ngala sine chlorine, sine water, spin the sibe nani, sibe ne copper on its own. So chlorine will win it over water, but chlorine kona ne copper ngala. So we look at between copper and chlorine ungala and copper ula pezul. So copper can easily be oxidized. So copper as an electrode, ion is over oxidized, not Cl minus. So ngala copper izosuga as a copper metal ipendugebani Cu2 plus. So what will happen here in this solution? Kushogutu zobona age ukuthi ama ions, copper as an atom izosuga la ibebani Cu2 plus. Kantu Cu2 plus will also be reduced ngala. So copper is oxidized, copper atom is oxidized to become a copper ion. Then the copper ion is reduced to become what? A copper metal, right? So we have that case. Mesege so sebenzisa nini lento for a certain application. Since the application ye electrolytic cell. The application yokala ibani iti electroplating. Electroplating. Electroplating is when you cover or you coat a metal with a thin layer of another metal. Electroplating. So electroplating. So quick exam, if they don't ask you a question about electroplating, kungaba ini electro refining. Electro refining of copper. If it's not that one, it will be the chloroalkali industry. That is the sodium the sodium reacting with chlorine. Chloroalkali industry, right? The electrochemistry in our sections out. So the first one lay hamsane galvanic cell. Yes, Billy is hamsane electrolytic cell. Then the first one, we electrolytic cell bazokulumange copper chloride. Either copper chloride, says kulumenge copper chloride. Siteni ugoti with copper chloride, copper will be reduced, but at the same time copper will also be oxidized, depending on what you have. So copper will be oxidized. Copper is reduced, but copper is also oxidized at the same time in the same solution. So if it's not about the composition of copper, then kungaba electroplating, noma electro refining, noma chloroalkali industry. So manisebenzisa ama past exam paper. Ikona any application engaseko, so don't stress. ye-aluminium. Extraction of aluminium. So mawubona into hambisana ne-extraction of aluminium, please forget it. I know ungathola i-pass exam paper mese uthi wena lokhu asekufundanga. Don't worry, vele akusekho, it won't be examinable. So kwi-pass exam paper make sure ukuthi ufuna into edila ne-electroplating noma electro-refining of copper or purification of copper mese kuba nani ne-chloroalkali industry. It's the same application masikhuluma nge-electroplating. Electroplating example is othi, let's say ngisebenzisa silver as a silver metal, ngifuna cover a spoon with a silver, right? Into fanuwaziyo, the first thing that you want to cover must be your cathode. Ngoba ilapho kuzokwenzekani i-reduction. Kunani kune cathode. Then we connect this one. Right, we connect this one to the battery. We know reduction kumele yenzekela. So we have the battery connected. This substance here that we want to cover it with, ifanele ibe kepi kwi anode. I solution yako ifanele ibe solution ye silver, a silver solution. Right. Now, by the time you connect a battery, ngoba makungekho battery akungeke kwenzeke lutho, ingakho sithi it convert what electrical energy into chemical energy. Now, uyabona ke solution mhlambe sine silver chloride, right? So this solution is just not silver chloride or silver nitrate, ngoba silver chloride is insoluble salt. Silver nitrate, masino silver nitrate uyazi ukuthi by the time we connect lo silver uzoshifta ngala. By the time u shift ngala, the solution is no longer neutral. So kuzoba o NO3 baningi o NO3 baningi ngala. So if silver ena izonzenjani will be oxidized. So silver will be reduced to the cathode, but at the same time silver will be oxidized from the anode. Excuse. Now silver will be reduced and silver will be oxidized. So bono ukuthi masibhala ukuthi oxidation half reaction, so the silver oxidized zoba Ag plus E minus. Again, don't be scared to use this table. Makutiwa write down the oxidation half reaction or reduction. Just copy as it is there, as long as you know ukuthi mawubhala reduction uzobhala njengoba injalo, but don't put the double arrow. Sebenza only a single arrow. But if it's a oxidation, you write it from left to right. Njengoba silver ngala ibhalo ukuthi Ag plus E minus, then there are two arrows and then Ag. So if I write it as Ag plus E minus, that means I write it as a reduction half reaction. Ngoba ngibhala njengoba injalo, the difference is that I put only one arrow. But mangi bala like ngipendula kanje uti Ag ungipela u Ag plus E minus, then that becomes what? The oxidation half reaction. Right? So silver will be reduced ngala, but at the same time silver will also be oxidized ngala. Into soyazi nge electrolyte ukuthi it will remain neutral. Isizathu ingoba the rate at which silver is reduced here is equal to the rate at which silver is oxidized. So any silver atom that has been reduced, oxidized ngala, it becomes what? A silver ion. The same silver ion will be reduced ngala. So the mass loss with silver electrode is equal to the mass gain with silver spoon that was covered. So ingaba is silver electroplating with silver, or it can be any other metal, chromium or any other metal. So the application yokala ishonjalo. The second application ile refining of copper. Same principle. Kwenziwa njani? Faga impure copper. Mese kufaga a pure copper ngala. Le copper inani inama impurities. Manje sifuna ukuyikhipha from lama impurities so that we collect it here. So my impurities can be other metals, whatever. Now sifuna bani 100% copper. So fanele senze njani, we connect this to the anode. So sinani sine copper solution. So again, copper ila kulama impurities will be oxidized. Uskipela bani Cu2+. Then the same copper will be reduced ngala. So zobono ukuthi mass yale copper will increase. So we are getting the copper ion, and the mass yale impurity is doing what? Is decreasing. Definitely kona amanye ama metals such as platinum or zinc, no man, that will also be oxidized. Kodwa ngoba copper in a stronger reducing oxidizing agent, copper will be oxidized. Lamanye ama ions azofoma ini a sludge at the bottom, to form a sludge, it won't be reduced, but copper will be reduced. So kunjalo. So ungadidiseki ke makuno uthola I diagram fakele into eyiningi, but it's just the same principle. Mase kuthiwa kanje, right? As long as you understand ukuthi the positive of the battery is connected kule, njengoba oxidation izokwenzeka ngala, then you still have what? The same principle, right? For copper, this is how the electrode refining of copper is. Kusho ukuthi oxidation half reaction ya copper, reduction half reaction is also for copper. So mangibhala oxidation half reaction, ukuthi copper is oxidized. So again ngisebenzisa the same table, so it will be Cu, ukipela Cu2+ plus 2E minus. Mangithiwa reduction half reaction, it's copper that is reduced, ungena ama electrons, ikipela bani Cu, ikipela Cu. So that is the other application. Second noted application ye chloroalkali industry. Sesiyenzile, but this time sidila nani sodium chloride. Most of the time we will structure SCJ. Right, this structure, a quick structure. Intefana nale. Usebenzisa bani a membrane. Sibiza ngani nge membrane cell. A membrane cell, right? With the membrane cell, monokuthi kune electrode eyodwa ngala. Then you have another electrode, local positive. So we have the anode ngala, we have our cathode. Lana kufagwa ini, kufagwa a sodium chloride, concentrated sodium chloride. A concentrated sodium chloride ibizwa ngani nge brine. It's brine that comes in. So concentrated sodium chloride is okipela bani Na plus no Cl minus. Mese ngala kufagwa ini, kufagwa amanzi H2O. Right, then water will come there. This is a membrane. Le membrane ibizwa ngani nge cationic membrane. Ayivumeli ama negative ion. So into edlulayo, it's just a positive ion. So ngoba kunjena, the chlorine will be oxidized ngala. Chlorine may oxidize ikipela bani chlorine gas. So ngala kuzopuma Cl2 gas. Right? Then Na agwa ufuna kwenze njani ukureduce gazi ufanele ezengala. So Na uzojomba ezengala Na+. Amanzi ayafika ke now. With water, we know ukuthi water, it can be broken into H+ no bani no OH minus. Then Na uzocompete namanzi. I think we've done that example ukuthi water will win over a sodium ion. Then water will be reduced. Water is reduced to ukipela bani H2, that is hydrogen gas. So at the end uzobona ukuthi kule solution kuzosola bani Na+ no bani no OH minus. Moba hlanganisa bakipela ini sodium hydroxide. Right, so our input katalizumona ukuthi kule equations like hlanganisa input NaCl, the other input H2O. Ama product etu kuno Cl2 kube nani, kube no H2 kupinde kube nani kune NaOH. Ingakho ibizwa ngani nge chloroalkali industry. Chloro ngoba sikhipha chlorine, alkali ngoba sikhipha ini ibase. right? It's a chloroalkali industry. So kwi-exam we-test bazokufakela u-X noma bathi A no B kuthiwa name the gas A or whatever into yenzekala. So here quick anode, it's a oxidation half reaction ga chlorine, ngala it's a reduction half reaction ga water, right? Yeah, so if you are able to apply these rules, then electrochemistry is obalula, right? So we wish you all the best, and electrochemistry is covered. So kubega next week. Siyabonga.
Ningakhohlwa ukuthi nisengathokozela ezinye izifundo eziyisithupha kanye nezengeziwe i-learner wellness, i-career guidance kanye ne-advanced program. Hlanganyela nathi kwizifundo ezi-online ku-068 151 1072 noma ku-GoDigi@godigitalsa.today. Siyabonga.